Just after the Big Bang, when the universe was still in its infancy and stars and galaxies were just beginning to form, humanity could not have imagined that one day we would possess the ability to peer so far back into time. For decades, scientists dreamed of a tool powerful enough to witness the formation of the first stars, the earliest galaxies, and the very structure of space itself. After more than 25 years of development, that dream has come to life in the form of the James Webb Space Telescope. The James Webb Space Telescope, or JWST, is now the most powerful astronomical observatory ever constructed. A collaborative effort between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, Webb was launched into space on December 25, 2021. Its mission is nothing less than extraordinary: to investigate the mysteries of our solar system, to observe distant exoplanets, to unravel the origins of galaxies, stars, and black holes, and to explore the very foundation of the cosmos. It is our new eye on the universe, and it is already delivering astonishing results. Unlike its predecessor, the Hubble Space Telescope, which primarily observes the universe in visible and ultraviolet light, JWST sees the cosmos through infrared vision. This seemingly small difference is what sets it apart and allows it to achieve what Hubble could never do. Infrared light has the unique ability to penetrate cosmic dust and travel across immense distances, revealing objects that are invisible in visible light. More importantly, the light from the most ancient objects in the universe has been redshifted, stretched into the infrared spectrum, by the expansion of space itself. Webb is precisely designed to capture that ancient light and interpret the secrets it carries from billions of years ago. In one of its earliest missions, JWST was aimed at a region of the sky that, to the naked eye, would appear empty. What it discovered there was beyond all expectations. Within that small, dark patch, Webb detected hundreds of ancient galaxies, many of which had formed just 300 to 400 million years after the Big Bang. In cosmic terms, that's like discovering adult civilizations at the very beginning of human history. What stunned scientists even more was the sheer complexity and maturity of these early galaxies. Conventional cosmology has long believed that galaxies take billions of years to grow and evolve. But Webb's images revealed massive galaxies with well-defined shapes, structures, and even spiral arms, features that should have taken far longer to develop. These galaxies appeared too big, too soon. Their existence challenged long-standing models of galaxy formation and forced researchers to question whether our understanding of the early universe needs to be rewritten. As if these discoveries weren't enough, the telescope also revealed the presence of heavy elements in these ancient galaxies. Elements like oxygen, carbon, and even nitrogen. According to the Big Bang theory, the universe began with only hydrogen and helium. All other elements were forged later in the cores of stars through nuclear fusion. The fact that we're seeing these heavier elements so soon after the Big Bang suggests that the first generation of stars must have lived and died far more quickly than we previously imagined, enriching the early universe at a startling pace. Another revolutionary capability of the James Webb Space Telescope is its ability to examine the atmospheres of exoplanets. Using a technique called transmission spectroscopy, Webb can analyze starlight as it passes through a planet's atmosphere. This light carries the fingerprints of the gases and molecules that make up the planet's air. By breaking down the light into its component wavelengths, scientists can detect the presence of water vapor, carbon dioxide, methane, and potentially even more exotic compounds. In a series of breathtaking observations, Webb has already examined the atmospheres of several known exoplanets. One planet, known as WASP 96b, showed the unmistakable signature of water vapor in its atmosphere. Others, like the hot gas giant WASP 39b, have revealed complex chemical compositions including carbon dioxide, something Hubble was never equipped to detect so clearly. These results are crucial stepping stones toward the search for life beyond Earth. If Webb can detect biosignature gases, like oxygen or methane in the right context, it could be a historic moment for science, potentially providing the first indirect evidence of alien life. And then, there's the search for Earth-like planets orbiting in the habitable zones of their stars. While JWST has not yet found a true twin of Earth, It has identified rocky exoplanets in the right temperature range. Scientists are especially excited about planets like TRAPPIST-1e, part of a system of 7 Earth-sized planets orbiting a red dwarf star just 40 light-years away. Webb is set to investigate whether these worlds have atmospheres, and if so, what they contain. Beyond planetary science, Webb is providing us with fresh insights into some of the most powerful and mysterious objects in the universe, black holes. The telescope has begun examining the centers of distant galaxies, where supermassive black holes reside. These giants, which weigh millions or even billions of times the mass of our Sun, may have formed much earlier than scientists expected. Webb's infrared eyes are revealing their surrounding structures, accretion disks, jets of high-energy particles, and star-forming regions that orbit close to these cosmic beasts. Some of the black holes Webb has detected are incredibly ancient. The fact that they existed so early in the universe's history raises new questions about how black holes form and grow. Were they born from the deaths of massive stars? Or did they collapse directly from dense clouds of primordial gas, bypassing the traditional stages of star formation? Webb may soon help us answer those questions, potentially rewriting the story of how the universe's most mysterious entities came to be. One of the most awe-inspiring images captured so far by Webb is the so-called cosmic cliffs in the Carina Nebula. This massive stellar nursery lies within our own galaxy and is filled with newborn stars, clouds of dust, and brilliant cosmic jets. Thanks to its infrared vision, JWST has unveiled regions of this nebula that were previously hidden by dense clouds, revealing the chaotic and beautiful process of star birth in exquisite detail. It's a glimpse into our own cosmic origins, showing how stars like our Sun, and by extension, planets like Earth, come into being. In addition to its scientific achievements, Webb has also begun to reshape our understanding of time itself. As the telescope peers further back, we are no longer just observing light, we are observing ancient history. Every photon that enters Webb's mirrors has traveled billions of years to reach us. We're not just seeing objects as they are, we're seeing them as they were when the universe was a fraction of its current age. It's a form of time travel, one that allows us to build a photographic history of the cosmos. But with each discovery comes a deeper mystery. Why were galaxies forming so quickly? Why do some stars appear older than the time available since the Big Bang? Is there something fundamental we're missing about the nature of time, gravity, or even the universe itself? Some researchers speculate that Webb's data may eventually point to a flaw in our current models of cosmology. The standard model of the universe, including the Big Bang, dark matter, and dark energy, has held up remarkably well for decades. But these new observations are pushing the boundaries of what the model can explain. Could there be alternative theories of cosmic evolution? Or are we simply witnessing a rare but possible set of events in the chaotic birth of the universe? Whatever the answers may be, one thing is clear. The James Webb Space Telescope is not just a tool of observation, it is a catalyst for scientific revolution. It is transforming astronomy into a discipline not of mere stargazing, but of deep time exploration. Every image it sends back is a piece of a puzzle that spans space and time. Every spectrum, every data point, brings us closer to understanding where we come from, what we're made of, and whether we are truly alone. And perhaps the most exciting part? We're just getting started. The James Webb Space Telescope has only begun its journey, and already it has raised profound questions and delivered unprecedented clarity. As it continues to scan the cosmos, uncover ancient galaxies, study distant exoplanets, and decode the chemistry of alien worlds, one thing is certain: humanity is on the brink of its greatest cosmic adventure yet. And here at Discovery at 2.0, we'll be with you every step of the way, bringing the wonders of the universe closer than ever before.